Guys, we're starting soon, so if the chatter could drop a little bit. Okay, we would like to welcome Rob Pickering, Eliza Camber, and Jason Berryman. And today they're going to be building your own programmable telecommunications infrastructure. Thank you for coming in today.
Thanks, folks. So the idea behind this is a workshop, right? So the idea behind it is that we're all going to develop some applications this afternoon. And hopefully we're going to have a whole lot of fun doing it. I was very nervous about bringing this kind of workshop to ConCon because I'm sure that, like folks in the room, are all building programmable telecommunications applications anyway. But the idea was to do something that builds some stuff in containers from first principles and makes the whole kind of thing accessible and easy. So you may learn absolutely nothing from this workshop, but you should have a whole load of fun. On the other hand, if you're coming from the workshop from the point of view of knowing nothing about programmable telecommunications and you want to build something, then this is definitely the workshop for you too. The idea behind and the objective of it is that, as I say, we have a bit of fun building some applications. We've got a few prizes that we're going to give away. I was hoping we're going to be using some of this tech in the workshop, like some Raspberry Pis and Pi Zero Ws and bits and pieces, but they literally arrived on the courier van in the last 10 minutes because of the Pi 4 release. But we've got some stuff that we're going to give away as prizes for the most novel application, the most purposeful application, and the group that has the kind of the most fun. Once we get into the presentation, or once we get into the workshop, we're going to kind of mix it up a bit and try and get folks with kind of different levels and different objectives to being here. But maybe the best thing is that the three of us all introduce ourselves and we look at the workshops that we're about to do. So I'm Rob Pickering. I've been doing programmable telecoms or telecoms generally. I started playing with Asterisk at 0.9 in the mid-2000s, building multi-tenant on-prem PBXs. So that's how long I've been doing telecoms. But really, I'm a web guy. So I started out my life building TCP/IP protocol stacks to try and get stuff connected to the internet in the 1980s for weird microprocessors that didn't already have them. And my perspective in telecoms has always been, why isn't this just more like the web? So what we're trying to do as part of certainly this workshop is containerize that some telecoms and just make it into a service that we can that we can use across the web, that an average web developer can use. I'm going to introduce Jason and Eliza as well. Now, I have to say that there are two workshops we're doing. The first one today is about containerizing up Asterisk, using it across ARI, and developing a few really simple applications based on that. We kind of shifted up a gear tomorrow in tomorrow's workshop, where we're starting to bring the media streams in and do stuff with Dialogflow and build chatbots. So whilst I'm going to kind of take the lead today, these guys really come into their own tomorrow when we start doing some fun stuff with natural language processing, natural language understanding with Dialogflow. So I'm going to let them introduce themselves today, and we'll kind of see the workshops as a continuation. Jason, do you want to?
Right. Good afternoon, everyone. I'm Jason. I realised that when I was making this slide on my laptop, it looked fine, and I realised this morning when I looked at the size of the screen that I was going to be huge. So here's little me and big me. Quick introduction to me. I kind of started life doing electronics and a bit of programming, and fell into telecoms really in about 1993, working with proprietary PBXs. Started out with SDX and then Splicecom, and I kind of got involved with Asterisk in probably 2013, so about 6 years ago. Been doing a lot of work with Asterisk. Recently got involved with cloud projects, so I'm now a Google certified professional cloud architect and a Google developer expert for Firebase, which is a suite of tools for aiding application development, and Google Cloud Platform, which we'll be using today as part of the workshop. I'm going to hand over to Eliza, who's going to tell you all about what she does and a bit more perhaps about what we'll be doing tomorrow.
Thank you, Jason. Hello, everyone, and welcome to our workshop. My name is Eliza Camber, and I am an Android developer and also an Actions on Google developer at Explicity, a tech creative agency that is based in the Netherlands and also in New York in the States. So you have the web guy, you have the cloud guy and the Firebase, and then you have the Android/Actions on Google. And as you can imagine, this covers all of those technologies besides the Android part. Unless you want to, I can talk about Android. And I'm also a Google developer expert on the Google Assistant and the Women Tech Makers Ambassador in the Netherlands. Tomorrow's workshop is going to be on Dialogflow and conversational apps. How does conversation works? What is the differences between Dialogflow, the Actions on Google, the Google Assistant, how all of these parts come together. And then we will have a workshop on how you can actually build your very own actions on Google using all the tools that we're going to provide to you.
Okay.
Rob, back to you.
It's all right, I've been wired. Okay. So, as I mentioned, I've been doing web stuff for decades and decades, and there's like a web way of getting stuff done, and generally that's having simple protocols, and really there's nothing new under the sun. So building services quickly and effectively boils down to how accessible is the technology, how physically accessible is it? Is it proprietary? Do I have to go off and pay license fees? Is it open? Can I pull in an open source project, modify it, maintain it, contribute back? They're the actual physical barriers to getting hold of technology, and then there's complexity barriers. So if you go back to the early 2000s, we started building these great big monoliths. Yeah, the stuff's physically accessible, but the project complexity kind of like goes out of control. So then we got those complexity barriers to building things. So we then we start simplifying things with REST APIs and microservices. So that's how we contain the complexity. And then running services efficiently comes from preserving economic choices, so not necessarily getting locked into proprietary services and proprietary platforms. It's kind of a bit hard to do this with telecoms, and okay, this is a bit unfair because I chose an IMS diagram, and really, you don't have to implement the whole damn IMS to receive a text message or do some sort of an IVR from a phone call. But the reality is that telecoms has traditionally been just a little bit too complicated for this kind of web treatment, that there's so much state in there and so many different components that it's quite hard to do. So you kind of got this clash. You've got web people like me that come along and sort of say, like, just putting that REST API on it, why can't I just open up a TCP port and do something like SMTP where it just kind of worked? And then we've got all this massive complicated stuff just to place phone calls and transfer stuff and all that kind of thing. So if you want to build a web application that interacts with the PSTN, and that, by the way, is what the workshop today is about. It's about building an application that bridges the PSTN and the web. Then you shouldn't have to deal with all this stuff, right? So there are a couple of ways of doing it, or a couple of ways of not having to deal with all this stuff. One model is this thing that we've kind of developed called CPassS, where you just pay someone to wrap all that stuff and take it away from you, the kind of the Twilio Nextmo model. So we take all of the complexity that's inherent in PSTN interop, and we just pay someone to cart that away and give us a REST interface to play with. And that's great, and it's fun, or rather it's easy, and it's accessible. It satisfies that accessibility goal, but it doesn't leave us unencumbered. It means that we're tied to that provider, unless someone comes along and clones their interface, of course, and makes it available in a different competing provider. But all the same, we're taking addition to contract out the complexity, but we might not necessarily need to do that. So another model is go and grab some open source, some absolutely awesome projects out there: Asterisk, FreeSwitch, Camelio, and all of the forks, Drachtio. Traditionally, the first two, because they've been around a long time, are deployed as monoliths. And I'm kind of sorry, Asterisk guys and FreeSwitch guys, but they tend to be great big monoliths with tons and tons of configuration around them. That makes them unapproachable. If I'm a web developer who just wants to get some stuff done, I can download Asterisk and I can figure out how to configure extensions.conf, and I can do one of David's absolutely awesome courses, and it will tell me a lot about it. But that's a massive, great big barrier to some of this stuff. just as an example, I went and had a look. We've got Asterisk PBXs all over the place, and I had a look at extensions.conf on a moderately small PBX that I think has about a dozen extensions and about 20 DDIs on it. And somehow, you know, we've got 5,300 lines of extensions.conf or something on there. Okay, it's all machine generated, it's script generated, but, you know, hey, that's kind of not the point, really. So the reasoning behind, you know, certainly the first part of this workshop was, can we actually take what we know and just encapsulate all this stuff and just make it into something that in about 10 or 15 minutes we can get someone up and running with a telephony system? So I thought, yeah, I'm sure we can actually. So if you take something like Asterisk, Asterisk obviously has got ARI, so that means that we can do a fairly simple web interface to telephony. And if we put a simple text-to-speech and DTMF interactions onto that, then we can just build that out of ARI. So we don't actually, you know, I can probably build a container that does that and just kind of starts with a couple of environment variables, talks to a SIP trunk, and we get something up and running quickly. And then we sort of, you know, talked to Jason and said, hey, well, actually, if we bring Drachtio and the FreeSwitch media framework into that, then we can probably connect it up to things like Dialogflow as well and do more complex real-time media interaction. So that was sort of the concept behind the workshop, really, was let's see just how simple and accessible we can make this stuff. So the workshop one that we're doing now, idea behind that, we're just going to throw up an Asterisk container. We're going to connect it to a Simrod trunk, because Simrod are fantastic and gave us some free trunk accounts. Where's Fraser sitting there somewhere? So as we work through the workshop, Fraser's going to whiz around and he's going to give you all a free Simrod account to plug into your Asterisk instance that you're all going to be throwing up. That's going to allow us to bring some calls in. We're going to write some code in Node using the Asterisk REST interface. And the third kind of component is just an open source text-to-speech engine that we're also going to throw onto our hosting infrastructure that then just allows us to effectively generate arbitrary text phrases. Tomorrow's workshop is going to be a little bit more ambitious, but I'm going to leave tomorrow for tomorrow. Let's see how we get through today. So one of the things that makes all this stuff possible is this whole idea of encapsulating things in containers. And the really, really cool thing about containers is that they're entirely stateless. And I kind of want to say that 3 times on the slide, because it's quite easy to start deploying containers in ways where you start thinking of them as kind of mini VMs and somehow figure out ways of capturing and committing changes to them. And at the moment that you understand that a container is just essentially a way of turning a complex pile of stuff into a program that is entirely ephemeral, may take a set of initial conditions, and it may acquire state from other things that it talks to, but that container is a completely disposable thing. That's kind of neat, because it allows us to do stuff like start an entire container that constitutes a running version of Asterisk with a couple of environment variables that allow it to connect to a SIP trunk, and just let it die after 5 minutes and start another one. And that's one of the things that allows us to put a lot of this telephony stuff into an environment that web developers understand, because we're just reducing our entire telephony worker into a thing that we can fire up, make requests on. So the Asterisk ARI interface is a key part of that. So this thing down here, and it's a built-in part of Asterisk, has been in for about 2014, something like that, David, that ARI arrived? Even earlier than that. And if you look at the evolution, as I say, I've been playing and using and making money off Asterisk for quite a long time. Back in the very early days, Asterisk was just dial plan, which is text files. Then AGI and AMI came along. AGI was a way of making Asterisk programmable, by effectively making script callouts in the dial plan. Some real issues around that and the single-threaded nature of it, so you end up blocking the dial plan and really reducing the amount of calls that you get through a system if you used AGI heavily. But in any case, you know, that's back to the running code on the same virtual machine on the same environment as your Asterisk instance. And about the same time as AGI, AMI comes along, which is effectively exposing the command line. So with a combination of AGI and AMI, you can sort of make Asterisk programmable, although it was quite hard work. But ARI fundamentally put Asterisk on the web, and there are a bunch of, on these slides, there are a couple of references there, and they're going to be quite useful when we get into the actual programmability part of the workshop, because we're going to be looking at some of those ARI capabilities and actually program against them. ARI is dead simple. We open up a WebSocket and we get a set of events effectively. So every time something changes, every time something lands in the status application, which is the place that calls that are being handled by ARI lands, we get an asynchronous notification through the WebSocket that effectively something's happened there, and it tells us a bunch about this call that we need to handle. And then we have a REST interface. REST interface fire a REST request in to do something. So there's a REST call there that plays a sound. This makes life incredibly simple for us to build a really easy web application. The really, really nice thing about this is that if you take it to its logical extreme, the Asterisk dial plan is pretty desk to us, because we can effectively reduce those thousands of lines of Asterisk dial plan down to something that says, yeah, when a call comes in, throw it into a status application and just go and ask ARI what we want to do with it, which is kind of neat. I lied a bit about that. In the Asterisk containers you guys are going to be running a little bit, that's actually the entire dial plan for the thing that you're going to be running. So, there's that status application, and it's included in a couple of different contexts where calls come in. I could probably have made that smaller, but that is the entire Asterisk dial plan for the container you're going to be running. Don't know if you can see how many lines of code there, but it's probably less than about 30. There's an application you're going to be running. That particular one plays a message, listens to some DTMF, and does some stuff based on the DTMF. And that's basically the size of something that's going to go and interact with Asterisk, accept a call when it comes in, play some free-form text-to-speech, and then react to DTMF that gets typed by the user. Let's go to the text-to-speech thing, because controlling call flow is great, but any useful application needs to be able to do random things. It needs to be able to take a piece of text, something that I've got from a web request, and turn it into audio and speak it back down the call that came in. Asterisk, and this is the since 2014 bit, actually, now I remember it, has had this facility that allows us effectively to go and instruct through stasis, through ARI, the application to go play a sound, and that sound needn't be something that's on a local file system. It can be something that you get from a URL. So if we construct an application, or we construct a service elsewhere that just takes a piece of text on a URL encoded command line, or URL encoded HTTP URL, and gives us a WAV back, and okay, the WAV format has got to be something that Asterisk can directly use, so generally it's got to be 8 kilohertz, then Asterisk will be able to play that, and it'll be able to play what it gets directly down the session. So the brilliant thing about this is now that we can actually effectively tell Asterisk to play a random piece of audio clip from text that we generate. So when I came to do this workshop and I was putting it together, I thought, okay, we need a really good text-to-speech service. And for certainly part one, this part of the workshop, I wanted to be absolutely clear that we were using just open source components for it, because there's no point kind of going to the trouble of doing this stuff if you than just go and plug in a third-party source to do something like this. There are loads of cloud services out there. Some of them are reasonably expensive. Because it's quite compute intensive, it's quite hard to find free text-to-speech services that don't get abused. So maybe we need to run one of our own. So I started looking at different TTS systems out there. There's Festival, which I think is an Edinburgh University open source application. A lot of the existing open source text-to-speech out there are based on various concatenation techniques. So that means that when I get a piece of text, I kind of break it down syntactically with rules, and I pull out either diphones, which are the little bits of, I guess, syllables in a way of speech, and I put it together, but I'm doing it rules-based, which means it can be a little clicky and a little bit false. But it can also be small and light. So the kind of three ones are Festival, Mary TTS, and eSpeak, these are really tiny things. Some of them you can run them on a Raspberry Pi, they're so small. None of them sound all that natural with the available data sets. So what I figured was, let's go and really have a look at the state of the art here if we're going to kind of throw some of this stuff up. There's some really interesting stuff that started with publication of a paper about something called WaveNet, Tachytron, Deep Voice 3, which are using machine learning to produce text-to-speech. And this produces some really quite realistic sounding text-to-speech. So it was a bit of a side alley. I kind of went down and started figuring out how to containerize some of these and put them on the web as a service. Didn't get very far with that because I found whilst a lot of these projects are really good as research papers, they're really very big. And doing anything like real-time text-to-speech using the results of any of these is quite, you need a lot of resources to do it close to real time. And certainly you need things like GPUs, which have got the matrix maths to be able to generate the real-time text-to-speech synthesis. And I was just about to give up and say, okay, no problem, we'll just throw at Mary or Mary TTS or one of the established concatenation systems. Where I found this repo by a guy who'd picked up some of the Deep Voice 3 results and figured out basically how to make it quite small and light. So small and light that you can run it on a single CPU without GPUs. So I grabbed and forked that repo, stuck a server on the front of it, and that's part of the source code that we're going to be using today. So we're going to be running our own little text-to-speech containers within the stuff we're going to be doing, so that we've got this truly portable thing that we really could deploy anywhere. Don't worry too much about the URLs and things. I'll give you a link to this, and we'll work through it as we do the workshop. And that's two of the services. So one of the services, actually, the best one probably is the Deep Voice Single, which gives us a single blended speaker. One of the kind of cool things they've managed to do with this is do learning based on a relatively small number of samples. So there's a good set of samples. I think there are about 22 odd samples of different regional dialects around the UK where they've got one speaker, and that actually gives some very, very believable voice. So I figured we'd make some of that part of the mix. So this is what it starts to look like now. The stuff we're going to be deploying is Asterisk 16 container, a bunch of environment variables that cause it to register a trunk and give us some credentials to talk to. We're going to deploy a text-to-speech container, and then we're just going to have some code that sits in Node that talks to them. So next thing, and I guess this is where Google comes in, I figured if we're going to run a workshop like this, we need people to actually be able to run these code on their own environment. Thought about sticking on Raspberry Pis, but then we need Ethernet switches and all that kind of thing. And whilst we can probably get the Asterisk on there, the TTS engine, certainly the ML-based TTS engines, are a little bit big for that. So I thought, okay, let's do it within containers that we can pretty much run anywhere. And then you get into sort of interesting stuff. So the Asterisk container is a little bit special because it's got to be able to receive an inbound. We're going to do TLS on this as well, because if it isn't secure, there's no point doing it right in 2019. So the Asterisk container has got to be able to receive an inbound SIP connection from the trunk provider on a unique public IP address on 5061. So we've got to kind of put that on the public internet somewhere. So figured, talking to Jason, we could just do that on Google's cloud platform, and there's a free tier. If you've got a Gmail address, you just sign up and get a $300 credit. So what we're going to set you up with this afternoon is have everyone sitting in the groups here running a container of their own on the Google Cloud Platform free tier. But of course, you can put it on any cloud platform you wish, or indeed your own. And as we go through the workshop, we'll go through how you do some of this specifically on Google, but also on your own platform if you wish. And then the Node code, you're just going to run on your own laptop that then talks across to the Asterisk 16 container. So it's probably about time to get started on some of this, I think. So why don't we get everyone started with setting up on Google Cloud Platform, and also getting a Symwood account. But before we do that, I think it might be quite a good idea to mix the groups up a little bit. So we're all on nice self-selected tables here of folks that we came with and probably are quite comfortable with. I think it'd be quite nice to kind of get a bit of a mix on the tables of sort of experience. Do you want to, if everyone's comfortable to do so, do you want to stand up? Come on.
The people with laptops might prefer to stay where they are, and the non-developers might be the ones who might want to move. But
yeah, okay. So maybe if we just sort of select up groups, and this is going to be fiasco, isn't it? I can see it happening. It's going to be a complete fiasco.
I've had one request regarding this. Is there any developers in the room that have never heard of Asterisk? Okay, any developers in the room that have used Asterisk but might want a little bit of Asterisk help, but you're really good at JavaScript? Mr. Duffett has offered his years of experience in Asterisk to come and join a team where he can learn about coding and he can help somebody learn a bit more about Asterisk. So who would like to take him up on his offer? There we go. We've got a table at the front here for you, David.
You see, I'm getting a total vibe from here of I'm sitting at the table I'm sitting at, I've plugged my laptop in, you're not going to make me stand up, and you're certainly not going to make me talk to any strangers. Am I right? Should I just give up at this point and not try and do that? Okay, let's stay in the groups we're in. Then that's I think going to be the best way to do this. Is there anyone here actually who's sort of the intended target of this workshop, who is perhaps a web developer, has got JavaScript, is curious about telecoms, but never done any telecoms before?
Okay, are there any
Fraser is the man.
Are there any JavaScript developers in the room? Because that could be a bit of a showstopper. And so we've got some here. So I think we're going to need a bit of hand-holding through this.
I think it's absolutely fine. I think we just stick with the tables we're in. Let's get some containers up and running. Let's get some hosts up and running. Get some Symwood accounts registered, and then we'll pick up the next bit about how to get the containers running on them. Fraser's going to wander around and get you set up with Symwood accounts. Jason, are you going to go through the how to get a Google account set up, or how to get a Google account?
Yes, indeed. So if you've got a Google account or a Gmail account, you can go to console.cloud.google.com and click try for free. What you may find is there's a bar at the top that tells you about activating your $300 free credit. It will ask you to put in a debit or credit card details, and that is there for verification. It won't actually charge you. And I believe, if Fraser can confirm, that's the same with the Symwood accounts as well. Where did Fraser go? Oh, there. The sign up for the Symwood credit. So you will need a credit or debit card to sign up for the free Symwood account, but you won't be charged. Fraser's going to give you, was it £500 credit or was it £5 credit?
A couple of zeros missing.
Right, a couple of zeros missing. Okay, we can add some more. That's a good question. That's a question for Rob.
Yeah,
Well-
the problem you'll hit running the container on your laptop is that when a call comes in, it'll hit 5060. So you'll register, and you'll register with the public IP address of the hotel here. And then when SIM will get a call come in, it'll try and place a 5061 inbound, which their firewall will reject. So that's why we're sort of doing this.
Okay. If you've already used up your $300 free credit, just go and create another Gmail account. Just call it, fred.comcon@gmail.com, whatever. So it's really easy to do.